In this problem, we're talking about two useful facts or rules in statistics. One is called Chebyshev's theorem, and the other is called the empirical rule. And there's kind of a detailed problem here about how some group did a study on companies that changed their names and how their stock prices went up a little bit, and they found out that the average amount that their stock prices went up was 0.71%. And then they said, suppose this mean applies to the whole population of companies. When we talk about large populations, the data often makes the same shape. So if you look at, for example, this could be the distribution of heights in a population. This is called the bell-shaped curve, and this represents many natural phenomena. Lots of data groups itself like this. And it makes sense. If you think about height, most people are around the average or just to the left or right of the average, a little shorter or a little taller. As you get more towards the extreme, there are going to be fewer and fewer people who are extremely short or extremely tall. Intelligence test scores fall into this bell-shaped curve, and many other naturally occurring kinds of data sets can be represented by a bell-shaped curve. So this is a useful model for lots of data. In this problem, we're going to assume that the distribution of these companies' stock prices is bell-shaped. And actually, let's do part B here first, because I think this is a little bit easier. It says, suppose that the distribution is bell-shaped if approximately 68% of the relative increases were between 0.59% and 0.83%, then the approximate value of the standard deviation for the distribution is what? Okay. Well, the empirical rule states that 68% of the data points are going to fall within one standard deviation to the left or to the right. So this way is one standard deviation, that way is one standard deviation. 68% are going to fall that way. The empirical rule says 95% fall within two standard deviations, and in 99.7 fall within 3 standard deviations. So in this case, it's telling us that 68% are between 0.59% and 0.83% of a stock price rise. So that means this value right here is 0.59%, and this value right here is the 0.83%. So if we want to calculate what one standard deviation is, well, we can take the difference here, and then this is actually represents a distance of 2 standard deviations, so we can take the difference and divide by 2. And we've got 0.12, and these are in percents of stock price rise, so the answer here is going to be 0.12%. So that is the value for a standard deviation in this distribution. Now, Chebyshev's theorem requires a little bit more calculation. Part A of this problem says, according to Chebyshev's theorem, at least what percent of the relative increases in stock prices lie within 1.5 standard deviations? I don't know why this says like. Lie within 1.5 standard deviations of the mean, which is 0.71%. So Chebyshev's theorem is a mathematical representation of a concept that's similar to the empirical rule. What Chebyshev's theorem states is that 100 times 1 minus 1 over k squared percent of the measurements in a distribution lie within this many standard deviations. So this is standard deviations. So all we really have to do, if we're being asked what percent of the values lie within 1.5 standard deviations, is just plug 1.5 in for k. So this problem comes out to 100 times 1 minus 1 over 1.5 squared. So let's calculate that. 1.5, and then we'll square that, and then we'll take 1 over x. We'll subtract that from 1, and we get 0.5 repeating, so 56%. And that's really all there is to the empirical rule and Chebyshev's theorem.